When we talk about automotive design, we usually look at how big manufacturers develop their cars. But with a company like ADRO, the challenge is different. The car already exists, the design is already there, but still the question is there potential for more? Can you improve the proportions? Can you sharpen the surfaces? And can you develop aerodynamic parts that feel like they belong to the car, but at the same time take it one step further for car enthusiasts? That's exactly what made this story so interesting for me. I'm Antonis from Product Innovation Lounge, and for this interview I talked to Davis Lee, Chief Design Officer at ADRO. We talked about the craft behind their part development, their international setup, and the role digital surfacing tools like Autodesk Alias plays in bringing design intent into production-ready high-end aerodynamic parts. So, hey Davis, nice to meet you again.
After how many years?
Yeah, right, correctly. I think we said is it 10 years? I think
something like that, right?
Yeah,
something like that, yeah.
I think I don't know, how many times have you been to Germany when we worked together?
Oh, a lot of times, but that was such a long time ago. Such a long time ago.
Yeah. But it's been great, and I'm really happy that you agreed to take the time and talk to me about what you're doing now, and maybe that's the entry. If you I don't know, maybe tell us what you're doing and what ADRO is doing that you're working for.
Sure. I am Davis Lee. I'm the Chief Designer and President of ADRO USA. What we do is we make carbon fiber aero parts for cars, wings, front lips, side skirt, diffusers. Also, we are expanding to make bumpers. Bumper modifications where it's not just the FRP bumper, but we take the same process of OEM, of making plastic injected mold bumpers made out of steel mold. So this kind of process takes a lot of effort into having the expertise of the knowledge that was learned in the OEM. For example, doing the clay modeling, and what's really important for us is having the 3D data where we can scan it and then use Alias to model it to Class A and then visualize it in VRED.
Awesome. So of course I checked it up before. So if I read it correctly, ADRO stands for Aerodynamic Development and Race Optimization. Correct? Is that right?
Correct.
And so yes. How are you involved in a typical project? Because you are, if I remember correctly, more a designer and maybe not the aerodynamic and race specialist. Am I wrong? I don't know.
Yes. So obviously there's many departments in a company, and what I think is really important is myself, I'm a designer, and we have Scott Beaton, who is our CTO. He's from Williams F1 Aerodynamics. So he was an aerodynamicist in the F1 for a couple years, and then he joined ADRO, where I design and he takes care of all the aero and CFD aspects of it.
And would you say that makes it more challenging for you, or how would you say is the split between visual design and aerodynamic efficiency?
Honestly, when I was in OEM, as you know, engineers and aerodynamicists, they're like enemies of designers, right? Yeah, they say, "Oh, everything." I know das ist schlecht, right? I think that's what they say in Germany. But the more
Correct.
I am in this aftermarket industry, I would say, and designing fast cars, what I realized that design and engineering at the peak, it always meets. So basically, what I'm trying to say is, fast cars by function, they already look really good in terms of design. So I think it's really by nature. Eagles look really fast looking. Pigeons look very slow looking, right? and they are actually fast and slow. So I think what changed my mind was that you can have the function work and have a good looking design. So they're not enemies anymore. And that's what I learned in this industry. making fast cars.
Yeah, that sounds actually really good because I remember the first part too. Like, das ist schlecht.
Yeah.
So would you say maybe turning to design at ADRO? Would you say there is a philosophy for you, like like remembering design philosophy for a brand, or are you following pure aerodynamics? I guess not, but yeah, I would wonder how you see that.
You know, to me, design philosophy, like there's only one philosophy for me. It has to look good.
Yeah,
I don't want to come up with like fancy words, you know,
yeah,
like
yeah.
sensuous or like timeless. No, no, it's like I don't know if this is politically right, but when you fall in love with a woman, you can't fall in love just because you explain how good she is. You just have to fall in love at first sight. And there's no explanation about it, you know? If you try to convince to like somebody, that's already wrong. So that's my philosophy, to be honest.
Yeah, I guess it's also quite challenging because you're not limited to one OEM doing body kits for, right?
Exactly.
So that
Exactly.
makes it especially challenging. So you already said which parts you're working on. Is it the same on every car? How do you decide what to do and how to change it? Is it like a certain pattern you're following?
So right now, what we're focusing on is more high performance cars. And we like it when the OEMs make a very boring front or make a very ugly front. And obviously, then there's a room for ADRO to change it to make it look better and make it look more aggressive, like a sports car.
So how would you say then? Because I've seen some of your videos, which I like quite a lot, like reviewing the newest OEM cars that they show online, and you are kind of giving you feedback what you think or how you would improve it. Is that also kind of the way that you are attacking your projects? Like, are you kind of, I don't know, zooming out and first trying to find the overall image that you will follow, or how would you describe your approaching projects?
So I strongly believe that there are fundamentals of car design. Like, I'll give you a prime example. Honda Civic is a mass production car. And then they bring a car called Honda Civic Type R, which is a high performance vehicle. And it's even wider than the regular Honda Civic. But if the Honda Civic Type R doesn't look like an eagle, it doesn't, and it kind of has that very blend look of a Honda Civic, then there is room for us to actually make the car look like what it deserves. So it's the same for BMW 3 Series and M3, high performance cars. So I see there's an opportunity when the high performance cars are not as aggressive or good looking as a normal car. I think that's where we step in to make it look like how it drives.
Is it that would be the follow-up question now? While you were talking, I was thinking about how do you select the cars that you're working on? Is it that pattern? Do you have like a schedule, or I don't know, is it like people request, or is it really when you see there's a good chance to improve that car a lot, and then you say let's go
Yes.
for yeah.
Yes. But there's one rule. The car has to perform. It has to be a performance car. Because, for example, if you made a bumper for Tesla Model 3, the owners of the Tesla Model 3, they're usually not interested in performance. Usually they're not interested in changing or modding their cars, making modifications. So number one rule, it has to be high performance cars. And number two, there should be a room for improvement.
Yeah.
Yeah. Yes. Yes.
Nice, awesome. And maybe covering also this aerodynamic aspect, are you evaluating aerodynamics of the stock car? So are you doing
Yes. So
tests?
yes, we do. So basically, wind tunnel test for us is it doesn't really make sense at our size. So what we do is we use open foam. It's a CFD software where all the OEMs also use. You actually, when we build things in data, we run a CFD test of a stock and with our kit on it to actually see how much downforce it makes or how much improvement it does. And then there's a lot of discussions back and forth with that.
Okay, I see. And how would you describe your clients, though? Maybe as a last question, like about the general like company wise. But I was wondering, how would you describe usually your customers? Because I think I saw on your website guidance for installation. Is it people who are installing the body kits themselves? Is it more like shops doing this for their customers? How would you describe?
So a lot of shops are capable of installing our kits. So if they're not comfortable, they can go to the shop. But I would say the combination is like half and half. A lot of people install it themselves. It's pretty easy to install. And our general clientele is, I would say, is car enthusiasts who loves cars, basically. Yeah. Yeah.
Yeah, that's what I've seen online on Instagram and the other
Yes.
channels. Yeah.
Yes. Yes. That's why we call it not for everybody. It's really not for everybody. It's really for people who love cars.
Yeah. I can understand, and I think it's really interesting to watch. I was really impressed going through all the content that I could find about you and the work online.
Thank you.
So talking about design at ADRO and workflows, digital workflows. Could you tell us a bit about the process from, as we discussed, your first idea how to improve a car and to finished parts? Like maybe first the overall process, and then we can go into detail where we think makes sense.
For sure. First of all, let me share my screen. Okay. So first of all, I think things that were not possible 15 years ago is completely possible these days. And obviously, which comes into a big role is Autodesk Alias, which we can actually work from. I'm in California right now, and our headquarters is in Korea, where we can go back and forth without looking at a physical model. It's because you can actually build things in 3D. But of course, in every stage of the design, what we do is, as you know, we start with sketches. I mean, this is my sketchbook, obviously. And before like 10 years ago, you would have to spend like days rendering just the front view. But with the help of AI, I was able to render this in about 30 seconds. So, and there's like, you can change the lighting. It's actually pretty crazy what, with what AI can do. What I just need to do is have a clear direction. So this is like, these are variations that I sketch something out and then work in AI to render it in different lighting and see, oh, okay, this is the mood I like. Then let's pursue this project. So I think the advancement of AI is helped us significantly in terms of efficiency. And then after I decided, okay, let's do this, then what we do, we go to Alias. Oh, I think it's beneficial to show a little bit. Wait. let me go a little more in details actually, because I have sub D data too.
Yeah, that would be anyway my question. Like, if you start right
Yes.
away in surfacing, or if you work with sub-D modeling.
Yes, I agree. So the beauty of after doing a rendering, what we actually do is we're not 10 years ago when sub D was not there, modeling a car, a bumper like this with NURBS would take weeks. But fortunate enough, what we can do is we take the scan of the inner compartment of the Honda Civic Type R. And then what we can do is we can model this theme very quickly in sub D. And I think it's really useful. Obviously, the surfacing is not perfect. All the zebras are twisted and everything, but it really doesn't matter because what we're trying to see is if this is going to work in 3D or not. And we found out that with this rough model, oh, it will work with the inner compartments without interfering. So after doing a sub-D modeling for about 5 days, we quickly move on to making a buck for a clay model.
How? So maybe just jumping one step back and then again jumping forward. So in that case, though, you're not only a design and alias specialist, but you're also looking at the quality of your 3D scan. You're also expert in 3D scanning, correct? Because you need to so you basically need to buy the car and scan it, or at least rent it.
Exactly. We have to buy a car. We have to take the bumper off. We have to scan everything that's inside, like this. This is actually, and the difficulty here is that when I was in OEM, when you design something, engineers get the specifications towards that design. But this bumper was designed, the inner structure was designed with a different design. And now we have to design over the structure and make it work. And that's where really Alias comes into place to actually see, okay, are we interfering with this? If so, are we going to move it out a little bit? How much are we going to move it out? Because we can't just cut this, right? So how much are we going to move it out to see if there's no gap? And then this could be very quickly studied in sub D. Yep, I think that's the beauty of it, yes.
So the first thing that comes in my mind is that you probably then have a huge collection of 3D scanned cars, I guess.
Yes, okay. Yes, we do. Yes, we do.
So you can 3D print a lot of models then.
Exactly.
I bet. And going on, so yeah, I can of course I totally get it. I mean, we worked together. I was the guy doing 3D models, and you were designing. Not on too many projects together, but at least we've seen each other there. And so I wonder, how much involved are you personally in this modeling, and how do you see the transition from sub-D to NURBS? It's pretty different questions, but yeah.
Yes, I mean, obviously there are alias modelers. Obviously there's a clay modeler, and they're very professional in their field, and I have to overlook at everything. But just to give you a little bit of insight of, okay, I gotta search a lot. Sorry, it's a little backpash. Please cut all this.
How many people are you in the studio? Together in both studios?
In US we have 8, and globally we have 50.
That's pretty good. That's good.
So here what you see is a 3D printed data based off of this, of the alias sub-D that we made. This is the 3D printed data. And then what you see here is obviously this part is, there's an offset and it's smaller. So we can add clay, and there's room that we can start modeling.
So is the right side, sorry, maybe I'm not able to grasp it, but so the right side, is it smaller because you put parts on it, or is it because you're gonna put clay on it? Sorry.
We're gonna put clay on it.
Awesome. Okay, I see. And then
So you see here there's a gap. Like
Yeah,
it's
exactly.
smaller. Everything is smaller. Yes.
Okay, I see. And then is it like the traditional process that you're putting a lot of clay on it and sending it through a mill?
Yeah. We don't mill it. We do everything by hand. I mean, because right now we don't have a milling machine. And second of all, it's not like a design studio where we have all the fixed XYZ axis. This car is not symmetrical. You know what I mean? So it's kind of hard to use a milling machine. So what you see here is a clay oven and a lot of clay. So that's how we do it. And
So-
then obviously, yeah, go ahead.
So it's maybe a technicality, but do you use reference points to know where you at with your clay model, or are you just like saying, okay, let's make it pretty and then scan it and then position it in 3D? Or I could bet that you could try to kind of triangulate, search some points on the A-pillars or something to locate where you at, or am I just like too complicated?
Like obviously there's reference points for technical issues. For example, right here, you see where it pops out here. That's the bumper beam where we have to avoid. So that's like, okay, let's cover this. But we don't have a technical point because after we're happy with the design, we put it into 3D again and make it work. So after this, obviously, comes the clay modeling. We put all the clay in there and then, start modeling. And what I can show you is that this is the final clay modeling that is finished, and you can compare it with the stock bumper, and that is the final clay model.
So it's like a really proper design process with all everything actually surrounding it.
Yes, and a mirror.
Yeah. I love it. I always love the mirror. It's
yeah. It's a cheat code.
It's a cheat code, but it's I love the simplicity and the effectiveness of a mirror, and in that case.
Exactly.
So basically now, let's say we are, I don't know, are we in the middle of the process of the project? Because I wonder now, of course, you kind of already said it, you would go into surfacing, but at which point is the aerodynamics coming into play? Is it already part of it? Did you already simulate the sub-D file, or is it coming later when you continued?
So usually when the aerodynamics comes in place, the front of the car actually is not that important in terms of aerodynamics. It's usually the rear of the car which is really important. Believe it or not.
I just believe you.
Yeah.
I will check later.
Yes, please check. Please check.
So, but in general, it would still interest me. So at which point in the process usually you would start taking? So basically, yeah, I understood. So the front usually is not that important for your aerodynamic improvements, but I guess then the rear diffuser and probably rear spoiler pretty much.
Correct. Yes. So which part it comes into place? I'll give you an example. Is when we do NURBS modeling, these are kind of the process that we do. For example, this is the Porsche project that we're working on right now. We are looking at all kinds of flows to make it seamless and to get less drag as possible and get most downforce as possible. So this this is how detailed we go in terms of we need to change the angle of the wing to get more airflow attached to the bottom, for example. And then I make the modifications in Alias to kind of not make this turbulence happen.
Ah, okay, I see. Wow, that's pretty detailed.
Yes, it's very detailed. The key is to get less turbulence as possible and most downforce as possible. So more downforce and less drag. So it could get into, yeah, go ahead.
No, finish your sentence. I just have a mean follow-up question.
Yeah, so this is a prime example of the wing where we got a pretty good number out of it. As you can see, the more blue you have is worse.
Yeah.
But all the lines are flowing with, this is a perfect example of having less drag and more downforce.
I see. How cooperative are you? Because we had it in the beginning of our talk that you are pretty good with aerodynamics, or that you said it very nicely that a performance car has to look good. But how is it in this case? So now you're going into these simulations and you have to change angles and stuff like that. Are you happily changing them, or are you challenging aerodynamic proposals?
You know, there's this saying in Korea, when a dog lives in front of education center, after 3 years, the dog can read a book.
Really?
What that means is, working 4.5 years with Scott, our CTO. Now I also have a sense of what's going to work and what's not going to work. So in the beginning, there was a lot of conflict, but the more knowledge I learned that, oh, this didn't work, that worked right now. So it's very cooperative in a sense. You know what I mean?
Yeah, I think so. Yeah.
Yeah.
So you also said that before, obviously, that you are working internationally, like in the US, in California, and in South Korea. So let's maybe the simple question first. So clay modeling, is it done on both locations? How are you splitting the process?
So as you remember, I was in Korea for 2 weeks. I flew to Korea, and then we started working on the clay model. And what you see right now is a finished model, but I've been working on it for close to 10 days.
That's not too much.
Not too much. Yeah. But it's very easy when I make the decision. You know, I don't have to wait for my boss to approve. You know what I mean? So.
I get it.
Yeah.
Okay, so and of course, clay is not that simple to transfer through a data cable. So basically, you're scanning. So you making the clay model, scanning it again, and basically your whole process has to be digital then to be able to sustain to studios.
Correct. So what I'm going to show you is it's the scanning process. So this is where, you know, we put all the dots, and then we scan it with this machine to get all the XYZ axis correctly into data. I'm sure you're very familiar with this.
Yes.
Obviously, no details on the grill, no details, but just the big picture, just the body. And here is our scanner, and what you can see on the screen it's real time,
Yeah,
capturing
love it.
the data. Yeah.
That's great.
Yes.
Awesome. And then you're going basically from that scan, you're going back into Alias and then doing a surface model, I
Yes.
guess.
Correct. So to give you a little bit of insight or visuals of how we do things. So we got the scan of the clay. Obviously, we just chopped the bottom off, but we got the scan. As you can see the surfacing of the clay and, some residue left over. The first thing that we do is when we get the scan, we have to check with the car to make sure, to make sure nothing is interfering with the inner parts. And we have to make sure that, for example, the wheel arch is not flush, right? So we would have to adjust all of this in NURBS. Now comes the Class A modeling, where with these points, we start modeling more intensively. Right now, we are about halfway done with our Class A modeling. And this, where is it? Yeah, this is the current status, where it's a hybrid of sub-D.
Yeah, exactly. That's what I wanted to ask, because I've seen the typical orange wireframe. So that's interesting.
Yes.
So basically, you are
Yes.
already in the process of making the Class A model, but you kind of the detailed. I mean, maybe you wanna tell it yourself.
Correct. I mean, the thing about these details, before, it was so hard to make it in NURBS, as you know. But with sub-D, what you can do is, maybe I think this curvature could be a little bit less round. I can just pull it, and just pull it and look at it. So I think this is a perfect way to experiment with meshes. And then obviously these are NURBS models where now the highlight is coming to life. We're still halfway in the process.
So that leads to I really like it, and it shows exactly the beauty of I think car design process also, in contrast to many other product development processes. But I would wonder about your opinion. So what do you think about surface quality? So is surface quality important to you? How do customers notice? How is it important in your current role? Why does it matter?
Surface quality for me is so important. And it's because not many companies go to the very last bit. I think it's the last 1% which a lot of companies are not doing, except for OEMs. So when customers receive ADRO bumpers, they're really amazed by the quality, but they cannot explain what it is. They can't. But I think that's the beauty of of a premium product, is to really chase that last 1%.
Yeah, I mean, I think it's exactly what you described, and I'm not sure if it makes sense to describe it to people, or if it's the beauty of it that people feel the difference. Like if you're not a car designer, you can't really tell right away what's wrong or why it's so perfect. But I think as a car designer, you already, of course, have the experience and you know what you're working all the time. But it's just like if the reflection works good, it's just a beauty. It just works with your eye, I think. And
exactly. And then I think that's the way to get goosebumps.
Yeah, very good anecdote. So, would you say, I don't know if the effect is really there, but I don't know if you have experience too with it, but do you think surface quality is impacting aerodynamics?
To our level, I don't really think so.
Yeah. I think you would have needed to do a really bad model.
Yeah, exactly. Like exactly. When you're doing nerves, it's really hard to mess up, right? So yeah.
So we went actually full in, and you you actually already said a lot about your modeling. Basically, okay, let's jump back to your process. So you currently you showed us the mix between Class A and Sub-T model, and then I bet you will finish it up so you have have all the data in NURBS and basically in the according quality, and then you still need to go for production, correct?
Yes, production is another category. But before I go into production, what I missed here is actually the VRED.
Thank you so much.
I think, what's really important here in VRED is that you're looking at a 5-meter long car in a 24-inch screen. So the sense of scale is not there. So the really important part for me is to get the data from Korea. They're working on it in Korea to get it on my side, put it into VRED, put it into different environments, put it into different colors, and then, and then actually seeing it with the goggle. This is what I use every morning when I get the data from Korea. And then with this, you can actually see the car in real size. Then I get an idea, okay, what I missed in the monitor, when I saw it with the goggle, I was like, oh, this is a little bit too straight. I wish there was a little bit more volume here. And just to give you what I was working on today morning is I am giving feedbacks. For example, this looks negative. So let's put it more, give more volume. And I wish there was a little bit more definition in the fender. All the lines, it needs to be a little bit tighter. All these kind of feedback. This could be only seen with a goggle because you're looking at a 3D object and in real size.
Really, I have to say,
I was like, when I show you this change, I feel like, oh.
No, it's the opposite. To be honest, it's like making me miss a bit working really directly on projects, like seeing all these lines and then seeing, actually, I see that too now, and then see how the model develops, how like all this detailing starts. Exactly what we said before helps making the surface really convincing and looking nice, and then having the highlights working. It's I really love working on this stuff, and
yes,
it's amazing.
Refining.
I try to find the right words. You are doing the visualization mainly for yourself. I mean, that's basically what it's for, right? So you can evaluate it in VRED, or are you using VRED for other purposes too?
For me, VRED is mainly evaluating in real scale.
Yeah, exactly. Because that's really an issue. Like I know that modelers started increasing their screen size immensely, but still, like it's not in car size yet. And then you're working on details on a headlight in that scale, and then you print it or mill it, and then you see actually in the whole context, it actually looks different. So I get it with the goggles.
Yes.
Great. Of course, like I guess that's of course like an easy way to get Alias data in here. So in VRED you're using, I bet, mostly, I mean, let's get a bit technical, hardware shades, so OpenGL, or do you
Yes.
use ray tracing on any sort?
I mean, I do use ray tracing, but GPU ray tracing is very powerful.
Yeah.
Like, I was shocked that I can even move it.
Yeah, that's true.
I was actually shocked. But mainly because I use it with the goggle, the ray tracing is,
not
I don't use it as enough because it becomes too slow.
Yeah.
Yeah.
I get it. And how about, no, you showed it basically, because I was wondering, so you have the model, you have the modeler working on it, you get the data, you have a look in it, and then you give feedback on a Photoshop file with line corrections and send it back, and
Correct.
they correct
Correct.
it. All right.
Yes, that's my daily workflow, you know, giving feedbacks. I wish this was a little bit refined. Showing, you know, let's try this with the meshes. So, and let's pull this out. So basically we're working 24 hours. When I sleep, they work. When they work, I sleep.
It's a never stopping
efficient.
machine. That's
Exactly.
quite practical.
Very,
That's
very efficient. Yes.
so
Yes.
so if you have modelers on both sides, Alias will never stop working. Although
Yes,
basically
yes.
you having you working with Alias too, so it is never stop.
Yeah, it is never stop. That's why we make it so fast. Yes.
Awesome. That's pretty interesting. So then, exactly. So you're visualizing it, you're having a look, improving it, and basically you're finishing up a surface model.
Yes. And then to explain to you, after all the Class A is done, then of course there's a lot of engineering involved to make everything fit to the car and to be able to make it as a plastic mold injection. Now this is a different project, but what I want to show you is to what extent we... Oh, sorry, I ungrouped it. It will take about a minute because the file is so big. I'll have a sip of vape.
That's the same mistake as showing all CVs. You pressing it and then you realize, oh no,
Yeah,
I have a 5-minute break.
Okay, I think it's ready. So what we do here is to make everything possible to be made with plastic mold injection. Now what you see here is all the different parts, even the tow hitch cover, even the sensors. So if I shade it, we'll see there's a lot of parts involved.
Yeah,
So
that's
this is
incredible amount
And
of
you-
work. And then you need to measure and position all the mounting points of the
Correct.
original part.
correct. And the problem that we have is that we don't have the production data, so we have to scan it, and obviously it's never aligned. So we have to measure with the ruler. You know, oh, okay, this is that, and then you know also this area, the mounting points where it gets very tricky.
Yeah, exactly. Oh wow.
Yeah. But it's all doable. It just takes time.
So, obviously there seems to be a lot of work to make it production ready, or at least there's a lot of detail into it. And when you finished with these parts, maybe I'm too easy on the workflow, but that's my impression. So you made the parts and then you're going into production, correct?
Correct.
And the parts that you produce, how is it with the customers? So you produce them and you send them like exchange part without paint, correct? Like this is that like the
Yes,
yeah.
correct, correct. They would have to find a shop who can paint and then make it work. So just to give you how, I don't know, let me show you, for example, yeah, this is how it goes out.
I
With
see.
hardwares, the bumper, all the compartments. So they would just have to take the stock bumper out and
Awesome.
then paint their bumper and put it in there.
All right, so basically, I assume that covers most of the process, right? So you basically start
Mm-hmm.
with typically with a sketch, sub-D modeling. You're using AI in the beginning of the process. I mean, it's a pretty hot topic right now. Everyone looks for some usage of AI. Is it currently
Mm-hmm.
the point where you use it, or are there some other use cases that you currently testing it or even having it implemented already?
I think AI in my workflow, we usually use it for renderings. But right now, what ADRO, we are developing a software called AOX, where we can optimize the shape in real time from 5 minutes to an hour if you want to go in more details. For example, this is the Porsche 992.1 GT3. We actually optimized the shape to give more downforce and minimum drag. And the software itself, with the help of AI, could actually change the shape. And what we did with this is we actually went to track with Liam Lawson.
Oh, really?
Yes,
Yeah,
and
I've flew over it, but I didn't go too much into detail.
he was able to reduce 3 seconds. So this is the. So he actually made a prototype on the Model Y. This was shaped purely from this AOX software.
Really?
And we were able, yeah, and because the real time and simulation is always different, and we were able to reduce 4.7%. We were able to gain 4.7% more efficiency with just this bumper. Meaning 100 miles range, it could go into 104.7 miles. And this is the 911 GT3 where the Liam Lawson, he actually tested it in UK. This is Scott, by the way. We tested it without it and with it, and he was able to reduce 3 seconds. So that's the result.
Oh wow, that must be
What,
fantastic. But that's a super interesting project. So basically, you get 3D data out of it then.
correct.
But
What it
this
does,
will, on the long term, basically, or quite sure, improve and change your workflow, don't you think?
I completely think it will, because you know very well designers, they finish the clay model and they get the selection. They send it to the aerodynamicist. They say, oh, this, you need to take this out a little bit, and then they go back to designers. And then, as you know, all the cars have this weird spoiler at the end because of aerodynamics, right? You know that, right? And what's very useful here is that you don't have to go to engineers first. You can actually simulate, okay, let's do 5% more efficiency. Then it will do a minimal shape, and it will suggest to you what shape you can work with. And then you can mill it into clay modeling and then make that beautiful. And then you will get an improved efficiency. So I think this is it's a process that will reduce the time a lot.
And is this something that you're working for yourself on, or because you obviously have a a name for it in a website? I guess you plan to offer it as a service.
Yes, so we initially developed this for ourselves, but we are also planning to offer it by end of this year.
Okay.
We're still in the beta phase right now.
That's really astonishing. Next to all all the cars I've seen on your desktop that you're working on, how much involved are you in this? Then are you looking over it from time to time, or is it more like a
Time to
software
time.
topic?
It's very technical. It's very software. So I am not heavily involved in this, but they are making it like the technology enhancement is very fast right now. So it's becoming very, very stable. And there's a beta test already. You know, there's a lot of clients already tested it. So we're working on it to make it more stable and easier to use.
I get it. Does this does this fit to an overall image that you want people to have of ADRO? I don't know. Is there a main mission goal that you have, or would you say it's just like because of the expertise you've seen that you might be able to share your knowledge and get out of this, not get out of this, but have a second foot you're standing on? I don't know, that would be the German wording you would use.
Yeah, I think I know what you mean. But just to, it's really funny because ADRO is, where is it? Oh, we got rid of it, sorry. Oh, here it is. Sorry, I can't find it. ADRO is not for everybody, but AOX is aero for everyone. So
that's good. Yeah,
it's very, very contradictory. But I think it's really important because you yourself has been in OEM for a long 10 years? You were at
around.
Mercedes 10 years,
Yeah.
right? Yeah. And do you have a background in aerodynamics or understanding? That's my question.
No.
No, right? Yeah, and that's exactly why we are developing this software. People, they're what they are imagining, and this is same to me 4 years ago. Oh, this would look fast, but I have no idea. And how to make a better aero shape? It's like I don't even know where to start. So, yeah. So this actually, it's so easy that even designers can use it. And that's the whole concept, aero for everyone.
I get it, but I love the contrast. Aero for everyone, but ADRO is not for everybody.
Yeah, not exactly. But the concept is very clear, yeah?
Yeah, no, I get it.
Yeah.
But basically, I would say this what you say is also kind of probably what you think that people should feel when they see ADRO car, because or not even feel when they see it, but when they own it. So basically, it's not for everybody. So basically, you really have to want it too, I guess. And
Yes.
and that's basically the styling too at some level. I don't know if I try to make it too easy.
No, it's very true. You want to be in that group, which is not for everybody. Yeah.
So just for interest, of course we know each other, and I've seen that especially the US is a big market for ADRO. How about Europe? Because obviously we are based in Europe, and probably a lot of people are watching out of Europe.
So we have increased sales in Europe, especially in United Kingdom and Eastern Europe. But Germany, there's a big barrier called TUV. I don't know if you're familiar with that.
TÜV.
You know,
Yeah.
TÜV,
Yeah.
and it's so hard because they have to do the material testing, crash testing, so many things involved. But we are actually on the process of getting approved by TUV. So we will open up our German office. It's already open. We have two people in Germany, two Germans, and we after the TUV approval, we will expand to Germany, which is the heart of car industry in Europe.
Yeah. Yeah.
Yes.
Okay, so that would be basically the hurdle. So as soon as you have this approval, people in Germany can get your
We'll be
parts
able to
and be
purchase.
able to
Yes.
drive them on the road in Germany.
Correct. Correct.
Okay, I get it. Awesome.
Yeah. Just to say about this process that I explained, 20 years ago, all of this process of the bumper that I explained would have taken at least 3 to 4 months to get into this stage because you would have to sketch, render in Photoshop, and then do NURBS modeling and, like actually physically go there, clay modeling, and finish it. But now, with the help of all these useful tools for designers, for example, SUB-D, NURBS modeling, of course, and VRED, and with goggles, everything, the time has reduced from 4 months to 2 months. And I think that's very powerful, especially when you're not physically in the same space. We are still able to work as efficiently, me being here in California and the modelers being in Korea, and keep on simultaneously working and looking at the same products. So I think this workflow is fantastic, something that we would have not imagined 15, 20 years ago. And this amount of efficiency is getting better and better and shorter because of AI. So I think it's a great use of advancement of technology, and then still getting the same output or even a better output.
What is the what is the one thing people usually do not see when they look at a finished part from ADRO?
What do you mean? Can you elaborate a little bit on that? What do they not see?
Yeah, like what is the part? Like what is something from a ADRO part that you spend so much time or you spend so much thinking, which is such a specific thing that people would look over it and not acknowledge?
I think that's a very good question. To me, spending time to make the 1% perfect, the last 1% perfect, as I mentioned to you before, nobody's gonna see it. But the feeling is there. So you know what I mean? So they won't see it, but they will feel it. I think this is really important. Just like the Porsche design. Porsche designers spend 6 months on the rear fender in clay. This maybe 0.5 millimeters more out. You know, and people, when they see it, they have no idea that designers spend 6 months on this rear fender.
Yeah, exactly.
And they have no idea how the surfaces meet. They have no idea how full or sheer the volume is. But as a product, they feel it. They feel that it is perfect, and they feel like, oh, this is different from other brands. And I think that's the beauty of spending so much time on things that people don't see, so that when they see it, they don't know it, but they feel it. And I think that's how I would answer. Yeah.
Yeah. Awesome. Very well said. I can just agree, and it's such a good example because it's just like
Yeah.
that. You see it and you feel it that it's just awesome, and it's it's always like seeing people sketching cars. They say, yeah, Porsche is easy, just making this and this and this, and I think like, yeah, the as you said, like the first 70 to 90% maybe, but then getting this perfection then starts to get really difficult, and this is
Yes.
when it sets apart. Yeah,
No, I completely
awesome.
agree. And that's the hardest part. Yeah, that's the
Yeah,
hardest part. Yeah.
awesome. Davis, thank you so much for spending after such a long time, so much time with me, and
Thank you,
sharing
Antonis.
your
Yeah.
process. It's
Yeah.
so interesting to watch, and I'm so happy
Mm.
that I never thought that we're gonna share excitement for for Alias together.
I, oh man. But really, really, thank you for your time, Antonis. You know, just talking is fun with you. So
Yeah,
yeah.
I really liked it.
Uh,
That's it. For me, this conversation shows very well how high-end design workflows and real enthusiasm for cars and their design exist far beyond the OEM world. To create parts like this, it's not enough to just have a good idea or a visual strong direction. It needs people who care about details and who know how design, surfacing, aerodynamics, and production play together. Most of this work is never visible in the final product, but it's exactly what makes the part feel right in the end. This is a good reminder of how much a good digital workflow can influence the final quality of a product.